Welcome my dear students and prep 3. Let's continue our algebra lessons. Today we will study the equality of two algebraic fractions. Algebraic fractions mean algebraic fractional functions as we mentioned in the last session. Okay, but before we talk about equality, we will reduce the algebraic fractions. How to reduce the algebraic fractions, or what do we mean by reducing the algebraic fractions? It means to put it in the simplest form. What do we mean by simplest form? It means there is no common factors between the numerator and the denominator. So this is the reducing of algebraic fractions. To reduce an algebraic fraction, the first step is to factorize each of the denominator and numerator. I'll factorize up and down in this function. Then I'll identify the domain. Before removing the common factors, I should identify the domain of this algebraic fraction. And finally, I'll remove the common factors between the numerator and denominator. So if I want to reduce the algebraic fractions, I'll factorize up and down, then I'll write the domain, and finally I'll remove the common factors between the numerator and denominator. For example, I want to reduce this algebraic fraction, and I'll mention the domain of each of them. The first one here, I have n1 of x equals x power 2 minus 9 over x power 2 plus 4x plus 3. I said the first step is to factorize up and down. I'll factorize numerator and denominator. X power 2 minus 9, this is the difference between two squares. So it will be x plus 3 multiplied by x minus 3. Here I can factorize the denominator also. 3 is 1 multiply 3 and the summation will be 4. So I'll factorize them. The numerator will be x plus 3 multiply x minus 3. And here the denominator will be x plus 1 multiplied by x plus 3. Okay? So what is the domain here? The domain is R, all the real number except the zeros of the denominator. What are the zeros of the denominator? Negative 1 and negative 3. How to get the zeros of the denominator? X plus 1 equals 0. It means x equals negative 1. This is the first solution. X plus 3 equals 0. It means x equals negative 3. So factorize up and down, then write the domain, and finally I'll simplify by cancel the common between the denominator and numerator. Here I have x plus 3 up and I have x plus 3 down. So the simplest form will be x minus 3 over x plus 1. The next one, x power 3 minus 8 over x power 3 plus 2x power 2 plus 4x. I can factorize up and down. Here in the numerator, I have the difference between two cubes. And here I can take x as a common factor, then I'll factorize. So the difference between two cubes, I'll take the cube root of x power 3, it will be x. And I'll take the cube root of 8, it will be 2. And I'll use the same sign. So x minus 2 multiplied by another trinomial consists of the first here power 2, then I'll multiply first by second, so 2x, then second power 2, which is 4. So this is how to factorize the difference between two cubes, and you can revise the video of factorizing difference between two cubes if you want. Here I have x is a common factor, so the remainder will be x power 2 plus 2x plus 4. Okay, can you factorize this trinomial? Can we factorize it? Here, if we get b power 2 minus 4ac, it will be negative. So this trinomial can't be factorized. There is no zeros of this this trinomial. Okay, so this is the factorization up and down. Now I want to write the domain. The domain will be r minus 0, only 0. Only 0 makes the denominator equal 0 if x equals 0. But this trinomial can't be factorized, and there is no zeros for this trinomial. As we see here, when we calculate b power 2 minus 4ac, the result is negative. It means that there is no zeros for this trinomial. So the domain here is only r minus 0. Okay, now we can simplify by dividing x power 2 plus 2x plus 4 by x power 2 plus 2x plus 4. So the remainder will be x minus 2 over x. And this is the simplest form. We reduced this algebraic fraction. Okay, what do you mean by the equality of two algebraic fractions? Two algebraic fractions are equal, and we write n1 equals n2 if the two conditions are satisfied together. The two conditions are satisfied together, not only one of them. The first condition is the domain of n1 is the same as the domain of n2. So they should have the same domain. Number two, after we simplify, n1 of x equals n2 of x, for each x belongs to the common domain between the two fractions. Okay, let's take an exercise. For example, in each of the following, if n1 and n2 are two algebraic fractions, is n1 equals to n2 and why? Okay, we will start our steps by factorizing up and down and write the domain, then simplify. I'll do that for both of the algebraic fractions. The first one, for example, n1, here in the numerator I have 2x power 2 plus 4. 2 is a common factor here, so I can take 2 as a common factor. Here I can take x as a common factor. So n1 of x equals 2 multiplied by x power 2 plus 2, and here x multiplied by x power 2 plus 2. Okay, so what is the domain? The domain, it means r minus the zeros of the denominator. The zeros of the denominator here is only 0 because x power 2 plus 2 equals 0. There is no solution of this equation. So the denominator will be 0 if only x equals 0. So the domain equals n of n1 equals r minus 0. We will do the same for n2. We have here 4x power 2 plus 8. So I can take 4 as a common factor. Here also we can take 2x as a common factor. Okay, but after simplifying n1 of x, it will be 2 over x. Let's move to n2 of x. I'll factorize. Here we have 4 multiplied by x power 2 plus 2. And here I'll take 2x as a common factor. Then I have x power 2 plus 2. What is the zeros of the denominator? Only 0. Only 0 makes the denominator equal 0. So the domain of n2 equals r minus 0. Okay, let's simplify. Here we have x power 2 plus 2 divided by x power 2 plus 2, so 1. And here we have 4 divided 2 equals 2, so the simplest form is 2 over x. Okay, let's compare. Let's compare the same domain or not. The domain here of n1 is r minus 0, and here also is r minus 0, so the same domain. What about the simplest form here? n1 of x, 2 over x, and n2 of x also 2 over x. So we have the domain of n1 equals the domain of n2, and also n1 of x equals n2 of x. So the two algebraic fractions are equal. So n1 equals to n2. Another one, here we have n1 of x equals x power 2 minus 2x over x power 2 plus x minus 6, and here x power 2 minus 3x over x power 2 minus 9. By the same way, step 1, factorize up and down. Let's factorize. Here we have a common factor x, so x multiplied by x minus 2, and here we can factorize this trinomial. X power 2 is x multiply x, 6 equals 2 multiply 3, and the negative sign here means that I have different sign in our bracket. The greater will take the sign of the middle, so 3 is positive and 2 is negative. Okay, what is the domain? The domain here will be r except or r minus the zeros of the denominator. The zeros of the denominator are negative 3 and positive 2. So the domain of n1 equals r minus negative 3 and negative 2. Let's move. Okay, we can also simplify. Here we have x minus 2 and here we have x minus 2. So the simplest form will be x over x plus 3. Now let's move to n2. n2, I'll take x as a common factor up and I'll factorize down as a difference between two squares. So here I have x multiplied by x minus 3, x plus 3 multiplied by x minus 3. This is the difference between two squares. X plus 3 multiplied by x minus 3. Okay, so what is the domain? The domain will be r minus negative 3 and 3. Okay, now is n1 equals to n2? Of course not. If I simplify here, it will be x over x plus 3. Okay, but the domain of n1 doesn't equal the domain of n2. So n1 doesn't equal n2. Okay, so n1 equals n2 only if the two conditions are satisfied. Here, for example, n1 of x equals n2 of x, but n1 doesn't equal to n2 because the domain is different. The domain of n1 equals r minus negative 3 and 2, and the domain of n2 equals r minus 3 and negative 2, so they are different. So n1 doesn't equal to n2. That's all about our session today. I hope you have understand. Our next session will be about operations on algebraic fractions. Thank you very much for watching. See you next session.